Today we're going to look at calculating comparative advantage using the input method and the output method. So the IOU and the OOO or the OOO method. And we're going to start with the input method. So what we mean by this is how much time does it take to do something? That would be an input method. Output would be what kind of product are we producing? How many widgets? How many buttons, how many whatever. The output is the actual product. So input method is time for the most part. So if you think about it that way, I think it'll make it a little clearer. Now in this example, input other under is what we're thinking of in terms of the input method, IOU. Input other under means you're comparing the two items that a particular individual is producing, or a firm or a country is producing. In this case, Ty and Jessica are mowing lawns and trimming hedges, or trimming lawns. And the idea here is that it takes Ty 60 minutes to mow a lawn, but 40 minutes to trim a hedge or a lawn. And what you're going to do is compare the time that it takes to mow and trim in opportunity cost of the other item. So in this example with IOU, by bringing over the input other under, 60 goes under 40, and the idea for trimming, and then trimming the 40 minutes comes under the mowing, 60 over 40, or 3/2 trims. And what this means is the opportunity cost of Ty mowing a lawn is costing him 1.5 trims. And so unless Jessica's is greater than that, it's probably going to be in his best interest to trim lawns, because he's giving up a lot of trimming in order to mow that lawn. Now what we see here is Jessica, it takes 75 minutes to mow a lawn, but 90 minutes to trim. And so again, input other under, if we do this for all 4 of these actions or activities, what we see is that 60 over 40 we started with in the first box is 40 over 60 with trim. So what that means is that in order to trim, Ty is giving up 2/3 of a mow in order to trim. And in that case, it's probably going to be smaller than what Jessica is giving up, which is what we see here. What we see with mowing for Jessica is that she is giving up, again, input other under, 75 over 90, or 90 over 75 for trimming, is what she is giving up in opportunity cost for trimming in order to mow, and for mowing in order to trim. So 75 over 90 is the amount of trimming she's giving up in order to mow, and so likely mowing is probably going to be her best interest. Trimming wise, again, 90 over 75, or more than 1 of mowing in order to trim is what she's giving up. So if we simplify these, what we get is 3/2 of a trim in order to mow for Ty, 2/3 of a mow in order to trim for Ty, and then Jessica is giving up 5/6 of a trim in order to mow. So it looks like she's giving up less than Ty is. She has a lower opportunity cost here, and thus the comparative advantage in mowing. And in terms of her trimming, she's giving up 1 1/5 mows in order to trim, where Ty is only giving up 2/3 of a mow in order to trim. He has the lower opportunity cost in trimming, and so he should trim lawns and she should mow the lawns. And that's the lower opportunity cost is the comparative advantage in this input model. So when they have a lower opportunity cost, they essentially have the comparative advantage. So Ty should trim lawns. He has a lower opportunity cost in doing so, 2/3 versus 6/5. And Jessica has a lower opportunity cost in mowing lawns, 5/6 versus 3/2 from Ty. So she should mow the lawns, he should trim the lawns. Everybody gains from that trade. And the idea of comparative advantage is that there are gains from trade in doing so. Now let's look at the output method. This is what I call, kind of jokingly, the OOO method. The output method is basically take the output of the other and put it over the item you're looking at. So if we're looking at radios installed, we would take the 2 from the speakers and put it over the radios. So it's 2 over 6, or 1/3 of a speaker that Mark is giving up in order to install a radio. So he'd be giving up 2 over 6. In the speakers, he'd be giving up 6/2, or 3 radios in order to install a speaker. Now, if we break that down for all 4 of these, for Doreen and for Mark, what we see here is that you have Doreen then, who is giving up output other over, so it's 5/2 or 1/2 of a speaker in order to install a radio. And then likewise, she's giving up 10/5 of a radio or 2 speakers in order to install the speaker. So in simplifying this then, what we see here is, again, output other over. So 2/6 of a speaker is what it's costing Mark in order to install a radio. But it's costing him 3 radios in order to install a speaker. For Doreen, it's costing her 5/10 or 1/2 of a speaker to install a radio. But it's costing her 10/5 of a radio to install a speaker. So if we simplify these numbers and reduce, what we see is Mark basically is giving up 1/3 of a speaker in order to install a radio, where Doreen would be giving up 1/2 of a speaker to install a radio. So Mark has the smaller opportunity cost here, and thus the comparative advantage in installing radios. Doreen is giving up 2 radios to install a speaker, where Mark is giving up 3 radios to install a speaker. So Doreen has the lower opportunity cost in installing speakers, and thus the comparative advantage. So Mark should install radios, Doreen should install speakers, because they both gain from trade in having a lower opportunity cost, and thus the comparative advantage in installing those items. I hope you found this helpful. Again, there are a lot of other videos out there, but I thought I would try and provide some clarifying comments on comparative advantage. So input other under for the input method, output other over, or for the output method or a product that's being produced. Hope you found this helpful.